Welcome to the demo of AutoCAST. AutoCAST supports the 3D methoding design, simulation and optimization of castings. It is well known for its ease of use, coupled with flexibility of application and single-click hotspots. AutoCAST helps to achieve desired casting quality at the highest possible yield in the shortest time. The AutoCAST processes the simulation and predicts the casting defects like shrinkage porosity, cold shut, misrun, blowholes, sand inclusions and mold erosion. Therefore, it helps to reduce the rejection rate in shop floor trials. The AutoCAST modules and functions are organized in the same sequence as per the Foundry practice. ViewCube for easy-to-use and powerful visualization. Snapshot helps to save the screen images of the AutoCAST. The user starts a new project by giving a unique name. These templates have many smart default values. Therefore, the inputs requirement from the user will be reduced. The STL file is taken as an input in the AutoCAST, which is the output of CAD softwares. The user can create the multiple casting layouts in a single file. It allows the user to compare the quality and yield of the casting based on it. Hence, it is very useful for the user to select a layout that gives better quality and higher yield. AutoCAST supports comprehensive range of ferrous and non-ferrous materials. Their composition and properties are as per the BIS standard along with customization. Here are some important thermophysical properties. These are used for the simulation. The user can change these properties if required. AutoCAST supports the wide range of mold materials as well. The user can choose the mold box size as per the availability in the shop floor. These properties give an idea about the mass and geometric properties of the part. Thickness function helps to find out relative thick and thin regions and their junctions. Hotspots generally occur in thick regions of the part. Therefore, we can also interpret directional solidification at that section. AutoCAST helps us to predict the cavity chord holes. With the help of this, the user can design the cores. Orient part. By using this function, the user can change the orientation of the model. AutoCAST supports both horizontal and vertical parting line. Stepped parting line is also supported. In AutoCAST, core and core prints design is a semi-automatic process. As we have selected the chord holes, now AutoCAST will design the core and core prints with respect to the chord holes. The user can modify core print dimensions and shape as per the requirement. Designed core including core print weight is 23.49 kilograms. AutoCAST supports multi-cavity layout design. As we have selected the smaller mold box size, we won't be able to select the multi-cavities option. Therefore, we need to select bigger mold box size. Multi-cavities layout helps to increase the metal to sand weight ratio. Also, we can increase the yield of the casting by using common feeding and gating system. Here, the user can adjust the orientation and positioning of the cavities. Hotspots. It is the last solidifying region in the casting. In AutoCAST, hotspot locations are predicted on the part layout itself within a few seconds. Ideally, feeders should be located closer to major hotspots. Minor hotspots can be eliminated by placing a chill nearby. Feeder design. It is semi-automatic process. AutoCAST supports various types of side and top feeder. The user has to select the required feeder and feeder neck shape. After clicking on Design, the AutoCAST suggests the dimensions based on geometric modulus method. The user can modify the feeder and feeder neck dimensions as per the requirement. The feeder gets transparent while creating the other feeder necks. Hence, it is very helpful for the user to design the feeding system in AutoCAST. Top feeder design. AutoCAST supports various shapes of top feeder and feeder neck as well. Check the hotspots result again. Here we can see that the feeders are showing its impact on hotspots. Feed aids are used when progressive directional solidification cannot be achieved by feeder alone or to increase the yield of the casting. Sleeves and covers. AutoCAST supports both exothermic as well as insulating material for sleeve and cover. Exothermic sleeve retain the heat for a longer time. It is effectively increasing the thermal modulus and thereby solidification time. Chill design. Chill increases the local rate of heat transfer and reduces the local solidification time. It is useful for eliminating microporosity. The user can also design the custom chill by using point list. Padding. It increases the local thickness of part to promote directional solidification. Padding portion has to be machined before casting delivery. Fin design. Fins are designed to increase the heat transfer from the local region, like chills, and help in reducing a minor hot spot. Breaker core. For the economical removal of the feeder, breaker core can be used between the top feeder and casting. It is also known as undercut core. Casting solidification is a quick solidification analysis based on hotspots. It shows the thermal isolation regions. It also helps in determining feeder locations. These are some of the feeder shapes that user can design in the AutoCAST. In the AutoCAST, gating design is a semi-automatic process. A blue gating plane corresponding to the parting position is displayed in the mold. The user is required to create the gating layout first, then AutoCAST will create 3D model of it. AutoCAST supports various sectional shapes for runner and ingate design. The trapezoidal shape has the advantages over other shapes. It includes minimum turbulence and discharge loss. Depending upon the gating system, either pressurized or non-pressurized, place the runners and ingates above or below the parting line. For the given gating design, the gating ratio is 1:2:1.5. The user can change the gating ratio as per the requirement and redesign it. Also, the gating dimensions are editable. The user can optimize the gating design as per the filling time. Filling time is inversely proportional to gating dimensions. These are some of the types of gating system that the user can design in the AutoCAST. Flow Plus generates results of coupled simulation of mold filling and casting solidification. This module helps to understand the filling and solidification related defects. Color map. It is given as per the temperature range. Media player. With the help of media player, the user can download the video as well. Filling result. It shows the sequence of metal filling in the mold cavity. Yellow color region on the casting surface shows the temperature drop. Filling time requirement for the given casting is 21.02 seconds and solidification time is 56.78 minutes. The velocity values can be displayed at any section during mold filling. The velocity values at ingates help in verifying the gating design to analyze the mold filling related defects like sand inclusions. Liquid fraction analysis gives an idea about portions of the casting which are still partially liquid at a particular instant of time during solidification. It helps to identify the hot spots and in assessing the pattern of feeding inside the casting. Isolated liquid regions have the chances of shrinkage porosity. To map the result of liquid fraction, we need to check the result of solidification and solidification time. Solidification result shows the temperature profile at the end of solidification. It helps to find out the temperature values at the isolated liquid locations. The user can estimate mold and core temperature values at any specific section. Solidification time result helps in understanding the relative cooling rate. Here we can see that the isolated liquid region is solidifying later as compared to the surrounding region. Hence the chances of shrinkage formation at that location is more. By the analysis of solidification and solidification time results, we can say that the directional solidification has occurred at the feeder region. Shrinkage porosity analysis helps to determine the macro and micro shrinkage locations and the volume of shrinkage porosity. AutoCAST also helps us to predict the depression shrinkage locations. Shrinkage porosity volume in the given casting is 670.23 cubic millimeter. The user can also measure the shrinkage size at the specific location by using grid function. Hard zones, it shows the rapid cooled regions. It suggests an area where hard zones occur during the machining. Thermocouple analysis helps to generate the cooling curves. By using cooling curve, the solidification behavior at a specific section can be analyzed. The user can place the virtual thermocouples in the casting as well as in the mold and core. It is a temperature time graph. These are solidus and liquidus lines for the given casting material. TC1 and TC2 represent thermocouples which are placed in the defect probable region and neighboring region respectively. Here, we can see the defect probable region is solidifying later when compared to the neighboring region. Hence, the hotspot is being formed in the defect probable region. TC3 and TC4 represent thermocouples which are placed in the feeder and connected part respectively. From the graph, we can say that the feeder is taking more time to solidify as compared to the connected part. Hence, the directional solidification has occurred over there. Blue and green lines show the heating curves for the virtual thermocouples which are placed in the core and mold respectively. Air porosity analysis. There are three options which allow us to predict possible locations of air entrapment by looking at air fraction, mole percent display, and fill time display. Air fraction. It shows air escaping sequence. The user can see 100% of the air fraction at the beginning from the color map. As the metal fills the mold cavity, the air fraction percentage will be reduced. At the end, the user can find isolated air pockets where the chances for blowholes is more. The user can generate the report in AutoCAST. This report includes the detailed information about the given casting. The yield percentage of the casting is 77.78%. The total poured weight of the given casting layout is 259.23 kilograms. AutoCAST benefits: improved yield by 7 to 10%. Rapid product development saves 75% time. In-time delivery with 30% schedule time improvement. Casting rejection goes down from 4% to 2%. Energy saving with reduced shop floor trials. Efficiency of manpower increased by 5%. Reduced casting rework by 10%. Also a safe investment and value for money.